Okay, today we have an 820-3115 that is coming with the complaint of liquid damage and no power. So, the first thing, of course, that we need to do is, one, see if we get a green light in the charger. So, if we plug this in, let's see, notice that we do not get a green light in the charger at all. So, as many of you know, the main rail we need to get a charger is going to be PP3V42. So on an 820-3115, that is going to show up at the bottom of the board, which I will show you guys right here. So on any of these boards, I have most of these points memorized now, but PP3V42 is going to show up right here, and that is 0 volts. That is missing. That is nothing. So PP3V42 is obviously the first rail we need in the system for anything else to work. However, if we look in this area, the whole area looks just really nasty. And what this tells me is this has been through an ultrasonic cleaner before. That is never good. It is never good to get a board that has went through an ultrasonic cleaner, or this was an electric toothbrush or something, because if you look, those layers are just coming apart, or the coating. So we're going to go ahead and pull this board out. And then we'll start troubleshooting. Another thing I wanted to incorporate in this video is failures. So, during your course of learning board repair or basically anything in life, you are going to fail all the time. It happens. So, this is something that happens to me all the time. This happened to me when I was starting. This, it happens fairly often. I mean, when you fail at something, you're going to feel like garbage. You're going to feel like you don't want to do something anymore. For example, when I get a run of boards that I cannot fix, it makes you feel like a complete failure. It makes you think, well, what am I doing? Why am I even in this line of work? When you get boards or just anything in general that you can't fix, or there's a repeated failure, repeated failures of the same exact thing that you can't figure out, and you're going to leave that day just feeling like a complete failure, like you don't know what you're doing. And that is something you're going to encounter. This has been the case, recently too, is because I've been noticing a trend that I don't really get the easy stuff anymore. What I get is either just not normal issues, but generally hard to solve issues, or just complete junk. So when that happens, you tend to start feeling that yourself. You start thinking, well, is it me? Am I not diagnosing the boards right? A lot of you guys know this, that same feeling. So, talking failures in general. When you fail, there's two things you can do. So, what you can do is option one, give up, and go home and cry or do whatever, and not go back and do it, or you try again. So, when I was starting, I wouldn't say I really failed at repairing my first board. There was a couple times, soldering resistor bad or something like that. Yeah, that's a failure, but that's not really a failure. That's a little screw up that you can fix, like a little soldering mistake and stuff like that. That's easy to fix, and you shouldn't beat yourself up about that. But there are going to be failures. There may be even bigger failures. You may miss an opportunity. There may be someone that wants to send boards to you, and then they end up not, or stuff like that. There may be something that like, let's say a store you want to lease, and then someone else gets it, or the landlord won't want to lease it to you, or stuff like that. So when that happens, and it's going to happen, like I said, you can either give up or just continue going on that same path. You should never give up for any reason. No matter what the failure is, you shouldn't give up. If you let just one little failure get to you, like something dumb like a soldering mistake or just anything like that, just don't do it. If I did that, I would never have gotten where I am at all. So, and that's the thing with having a going to encounter stuff like that. You're going to leave someday feeling like a complete failure, like like you shouldn't be doing this. That happens sometimes, and it's just part of it. And it doesn't mean you're bad at it. It's just part of it sometimes. So this board is apparently missing PP3V42. If we look over here, I wonder what this is. And that's nothing. Let's plug it in and check. So still no green light, of course. I'm just going to double check PP3V42 maybe on a different point since that's all corroded. But one more time. There's nothing there. I think this one is 3V42 as well. And obviously we're not going to get PPBus G3 hot, as you need PPBus G3 hot to even generate your, you need 3V42 to generate PPBus G3 hot, obviously, and of course that's 0 volts. Wait a second. No, that's not. That is, less than a volt, which is typical. Usually you'll get about 1 volt on PPBus when 3V42 is missing. So the next thing I'm going to check is our ACN or DCN. And that is 16 volts. So now we have to go trace this back. So let's go ahead and pull up a schematic. This is a 2012 A1278. Now this was sold from 2012 to 2016, and what you'll notice is a lot of people will buy this in 2016 or have bought it in 2016, and they end up thinking that they have a 2016 MacBook. And then you have to explain to them that no, this is really a 2012 MacBook that Apple sold to you for a ridiculous price that still has an Ivy Bridge CPU. So display capture. So here is our MagSafe DC jack. So we just check this fuse right here, or voltage on the other side of the fuse. How this is going to work is we're going to take voltage from our charger, of course, and that's going to go into obviously DC in fuse. Here's our one-wire protection circuit or adapter sense protection circuit. Both of these chips are going to be the one-wire circuit. Real simple. You don't even need to know what these do. However, this is related to the one-wire circuit. And then, let's see, where's our 3V42? It's down here somewhere. I'm thinking of a different board. Come on, where is it? Right here. So, we also notice that here's our 3V42 generation circuit. So, this is either going to work off the battery or the charger, and we're going to do this, of course, to a couple of resistors and a diode. That allows both, we could both generate this off of either the battery or the charger, as many of you guys know. It's going to go through a couple of resistors and a regulator. Regulator is going to output a switch line to an inductor, and then that is going to give you your PP3V42 power line. Now, something here is not working right. So, between our, come on, scroll quicker. Between our charger from right here, either something in this area between the MagSafe jack and this circuit is not working properly. So we're going to go ahead and see if we could find that. So the first thing we're going to check is voltage on both sides of D6990. So we're going to go ahead and do that now and see what we get. Switch back to microscope view. So D6990. Let me pull up a board view for this board. And that is going to show up right here on this. And those are two resistors right there too. And first thing I'm going to check is output on the diode, and that is 16 volts. So we're good. This diode is good. Obviously we're not going to get, we're just going to measure G3 out voltage right there, which is obviously low. So our diode is good. So now we know we have another issue. So what we're going to do now is check for a short on since here's the regulator also. This doesn't look too nasty. It still could be bad. However, I don't want to just go replacing this because it's right by the RAM slot. I don't want to melt that. So we're going to go ahead and check for a short on our 3V42 output. And we'll do this right over here by the SMC. And we have a dead short, at least right there. I'll double check in another area. Yes, and we have a dead short on PP3V42. So we're going to go ahead and find that, but we could probably guess it's going to be something in this area. Like this little cap right here does not look too healthy, so you know what, we might just elect knocking this cap off. Like that. And rechecking it, because you never know if that was just it. I don't really want to inject voltage if I don't have to. And maybe we'll get lucky. And that was it. There was no more short on PP3V42. So if we plug in the charger now, what happens? Notice we have a green light in the charger and a spinning fan. So this MacBook is basically working. However, you see all this junk right here? Can we really trust any of this? What's going on with my microscope here? So this area does not look very healthy. Obviously the probe points are all falling apart. U6901 doesn't look good. Some components for Thunderbolt doesn't look good. I mean, this cap is completely gone. Yeah, so what we're going to go ahead and do is clean up this area. We'll probably replace all this nonsense, because you see that cap, what probably happened is that this went to another shop. Another shop ultrasonic the board. It worked, of course, so they just said, okay, it's working, sent it off. Now, a lot of repair places will do this, and this is one of the things that makes my repair shop different, is we don't leave stuff like this on the board. We don't just give it back to you if it works. We make sure it's 100% fixed and ready to go. You know, when it leaves here, I don't want you to get something back that's going to last you, you know, a couple months, then die. So I'm going to go ahead and start by just repealing and replacing all of this. Also, there's going to be junk under the SMC, as always. So I'll go ahead and remove the edge bonding on that and give it a light reflow. So back to the thing about, you know, failures and stuff. One particular thing that as a business owner you are going to experience is you are going to have days where you feel on top of the world. You know, you're gonna leave your shop or wherever and just feel great. You know, you had a great day. And then you're also going to notice you have the contrary of that. So one thing to note is, you know, there's so many people, and this is including myself, is that just worked really hard to get a store and you know, expect the stress to go away and stuff. Not necessarily go away, but generally you think, well, you know, now that I have a store, things you know, should be a little bit easier and this and that, and oftentimes that's not the case. So yes, you will get more work in. That is a given. You know, a lot of times, like especially when I was based out of my house, is people just did not have the trust. They did not trust in a home-based business, and therefore that would affect the business you get in. So then you get a store, and you're going to notice that there is a lot more work coming in. You know, but the stress that you're experiencing when you were starting, and most of that would be, you know, not having enough work in, or just something like that, is going to transform into having too much work in, and then having to deal with that, deal with the screaming people that are upset at you about not getting stuff done. And another thing about local customers is sometimes they want it done fast. They think that there's no link. They don't see it from your point of view, and they don't understand you know, what's truly, they don't understand that it's going to take a little bit of time to figure out their issue. You know, like sometimes people will lose it over 3 to 5 days. You know, when you tell them it's going to take 3 to 5 days to fix something, sometimes people don't like that, you know. So what you'll notice is oftentimes your stress will just be transformed into something else. It's not to put you off on having a store. You should absolutely, do what's what you feel is best for yourself. However, that is one thing that I thought which would be that, it would be a lot, happier and this and that having a store, and that's often not the case. It's just transformed into something else. Not saying that that things are bad or anything like that. Just in general. Alright, so just have to go ahead and replace some of this stuff. There was a cap right around here for Thunderbolt. We don't want to disturb this chip or reflow this chip. Actually, yes, I do want to reflow it, but I don't want to get this junk under it. And this junk did not come off in one piece, so that's going to make it a little bit harder. It's real easy to chip these glass chips too. Yeah, this board is just torn up. No good. We'll fix it though. This is why you don't just put boards in the ultrasonic cleaner. I see this all the time where shops say, oh, liquid damage treatment with an ultrasonic cleaner and this and that. No, fix the board. Do not just blindly put stuff in an ultrasonic cleaner. It's not, an ultrasonic cleaner isn't a magical tool that's going to fix liquid damage. Sure, it helps, but I want to make sure this SMC is fully reflowed. So now I just have to start the painstaking process of cleaning this all up. Another thing I see people get stuck on is practicing. So, I've seen, I've helped and dealt with several people that have been learning over the past 2 years, right, when I've started, and I see some of them are still stuck on practicing, where they think, oh, well, I don't have enough experience to go into customer devices and stuff like that. Now, here's the thing. When I started, I did not buy broken stuff off eBay. I did not fix that before going to customers. I jumped right in. Now, by saying this, do I mean you should just go and blindly replace an SMC on a customer's device without knowing what you're doing and never soldering on a board before? No. What I did is I got donor boards and I practiced on donor boards until I was confident enough with soldering. And, the whole time I was actively advertising and stuff, so even if a customer's device came in, I would have worked on it. But I never had that phase where I just sat there and practiced for 4 months until I, felt like I was confident enough. I just jumped into it, and that's what I recommend a lot of people do as well. Just make sure, of course, then again, I'll probably shouldn't say that because there's going to be someone that's truly incompetent that's going to screw up someone's device. But generally speaking, don't get stuck on the practicing phase. It's not, you don't really need to practice for 2 years, The best thing to do is just jump into it. At least that's in my opinion. Just start. Don't get discouraged. You're gonna screw stuff up. Stuff isn't gonna, it's sometimes you'll get those days where you really just can't make stuff work, and that's okay. It's part of it. But just don't give up. Don't, like I said, just don't get stuck on stupid stuff. So these resistors, generally I'll leave resistors on the board. We could touch these up. They're a little bit oxidized, so that's not a problem. This I'll fix in a minute. This cap is pretty bad. So I'm going to go grab a donor and we're going to start replacing everything that I took off. Generally speaking though, it's not too hard to get into this. You just have to get past that initial learning curve and then you'll be set. This area is going to need a few jumper wires as expected, but at least the actual issue was, fairly easy to solve. It's nice, easy little 3v42 short. You see how this trace is just falling apart? That's what happens when you put a board in the ultrasonic that's all corroded. Always address corrosion properly. I have no doubt this will work. This won't work after this. I know it's going to work, but still. Yeah, see how it just fell apart? This would have been a whole lot easier if it wasn't run through an ultrasonic cleaner for 10 minutes before work on it. Whenever you get a little resistor like this, sometimes the pads underneath will be gone, but in this case I don't think it will be, as we just I'm going to go through and wick this again. I just kind of wanted to restore some of those connections. Now I'll go ahead and wick the excess off. Alright, so that's on the same plane as this, so we could just go ahead and bridge that over. That's fine. That little resistor, or whatever that was, okay, I see what it is. So it is... Alright, so these two resistors are for PCH, SO, PCH, VCC. There's a cap that goes there and a cap that goes there. And then the chip, so we'll just make it kind of like a mess, a working mess of MacBook board. Actually, I'm going to remove this solder until after our chip is soldered, because I do not want that to bridge. first thing I'm going to solder is our chip. I'll probably conformal coat this area too, just because of how exposed and how nasty it is. I just don't trust it. And what's next? Let's see. This big cap, which is stolen off my donor, so I'll go for this coil. The main thing I'm concerned about is the caps, because these can short after some time being liquid damage, so I don't care about the resistors, because the resistor isn't just going to fail down the line. It would take a short or something to make a resistor fail, and I'm not too concerned about that happening. The main thing is those caps, those little ceramic caps that are going to, short over time. Okay, and now what goes right here? I have to kind of compare it to the donor, since this is all just, corroded. And still at this point of doing this, I still find it hard to believe that my simple idea of doing this would have ever, came this far. So there's going to be two caps that are supposed to go from right here. I think they go like, so let's see on the donor. Okay, I see how those go. It's hard because you don't see pads because the coating is just off. You just see mess. And now I see bigger mess. And I lost that cap. This via going under the SMC doesn't look good at all. So I will resistor and via. You know what? Better safe than sorry. And some of you guys may be thinking, well, what about all this heat on the SMC? It's fine. You do not have to be concerned on an SMC. If it was near the CPU, absolutely. SMC, no. So we'll do U6901 next. That'll probably run a jumper over, 'cause I don't want that coming back. Additionally, there's a cap for Thunderbolt right here. Then there's another resistor that goes right here, but that's all torn up. So what I'm going to do is try and figure out a solution. Since that's going to go on pin 1 of that resistor. So in this case, firstly what I'm going to do is wait until last to do that. But, so we have PP bus G3 hot on this side, and then we have BST power EN something or other on this side. Notice how, same thing on the resistor, this is going to be PP bus. So what I'm going to do is I'm just going to sit this resistor down right here and just make sure it's making contact on that capacitor. But first I need to finish everything in this area, because I don't want to blow that away. So this is looking pretty good. I'm just going to go ahead and, I don't trust the soldering under these, so I'm going to put a little bridge right here. Make sure those are connected, that's good. We have one little cap right there. Let me go grab another donor board. All my 3115 donor boards are getting really barren. I should order some new ones. Alright, I lost that other one, but I'm pretty sure this is the same value, so I'll double check that, but I'm 90% sure it is. Let me just double check. Darn it, it's not. I blew the other one away just right now again for the second time on that same capacitor, so I thought I could just take the one right next to it, but it appears they're different values, so don't want to do that. Back to the donor pile. I'm gonna try not to lose this one, because the donor board's supply is not bottomless. Well, it sort of is, but this area is almost rebuilt. Almost done. Then ultrasonic, check the rest of the board. conformal coat all of this because I don't like leaving stuff like that exposed. That's just a personal preference. There's really no harm in it, but I just would rather have the solder. Anywhere that has these big blobs of solder like that, I always just coat because it's generally more professional. You know, and if I opened that and saw that, I would think, well, you know, what was this person doing, leaving all this exposed? And I don't know, maybe it's just me. I do not want to get solder on the top of that. Oh, come on, whatever. We'll replace you too. Probably better to go anyway. And I think that's it, except for one little cap. I think that's the right one. We'll know sooner or later. And then what I'm going to do is take a wire, and see, this trace is just falling apart. If you drop the computer or something, I don't really trust that to work. So I'm going to take a little wire, solder it right here. A little bit of more solder in here. There we go. And then I think the last one, so I wanted to investigate real quick what this, this was all torn up, but I want to see if that's a connecting trace or anything like that, and it is not. It's just a no stuff. Yeah, so that's none of our concern. So the last thing to do is that a resistor right here, since the pad is gone, what we're going to do is just sit it up against that capacitor. Might be a little bit tricky, but we'll get it. I'll just do it with my iron. I don't want to blow it away. And just like that, that is done. So this board is going to get ultrasonic. Let me test it real quick just to make sure I didn't make it worse. Always like to do that. So green light still. Hasn't screwed anything up. And we still have that nice fan spin. So I'll be back and I will show you guys the finished result after it's ultrasonic and conformal coat run over everything. That's boring, straightforward, so not going to show that on video, but I will definitely post it at the end, and thank you for watching. This is after the board has been through the ultrasonic cleaner and I have conformal coated anything that was exposed in this area. So that's just for, a little bit more durability and just to be a little bit more professional, if you will. Area looks nice and clean and this works. So just because there's going to be someone that may say that this wouldn't work, I'm going to start this and you guys can see the Apple logo. Wait for it. It'll pop up. It's a 2012 A1278 with a mechanical hard drive that probably has a failing drive cable. That's super common in these, so it'll take a minute for it to come up. Hard to believe that people would still buy these in 2016, but they did. And there you have it. That is a Apple logo, and that means this board is fixed. So that's it for this one. This was a pretty interesting repair, so I hope someone enjoys this video, and I hope this helps you solve your problem if you ever have an issue in your PP3V42 circuit.